Yes, I know that. No! Don't touch my leg. No, what?
So here's an example of polynomials. So polynomials can be anywhere from one to many terms. Okay. So when we put the only requirements with polynomials is it can't be a polynomial if you have an exponent that's negative, or if you have a square root on the exponent, or coefficients that are square roots. That's not considered to be a polynomial. So, standard form.
Whoa! What's up?
Okay, so there's an example of a polynomial. I'm going to put it in standard form. When we put it in standard form, we go, this one is in standard form, this one is in standard form, and this one is. What do we notice about those exponents?
The higher exponent is to the front.
The highest in the front, and what else about the other exponents? Very nice. Descending order. Those exponents are in descending order. I'm just going to write exponents in descending order. So all of these up here for the examples, those were already in descending order. That's standard form. So remember, standard form for a quadratic was ax squared plus bx plus c. Those exponents were also in descending order.
Wait. You have to like. Would you write them?
So I'm sorry, I just decided not to worry about that. You can cross it out. Okay, so number one, we want to write this in standard form. So we want to go the highest exponent first. So what's the highest exponent term?
2x.
Which one is 2x squared? And then we want to go descending order. So what's the next highest?
3x.
3x. And then plus 1. So that's descending order, so it's standard form. So what on number 2? What would come first? This is the easiest part, so I'm going to quickly go through this. What goes first? 7k cubed. Highest exponent is 3. Then the next highest is k squared minus k and plus 64. What's the highest exponent here? It's a 3, right?
Yeah.
Yeah. So w to the third, and what comes next? 5w squared. And then what next? Minus w plus 28. Highest exponent here would be n to the third. So what comes next? N, and then plus 24. So we don't do polynomials with multiple variables very often. But if we do, the way we want to do it is we want to use alphabetical order. We will look at the first one in the alphabet. So that would be A. So that we want to look at the highest exponent on the A's first and ignore the B's. If there's something in that term that has a B, we just look at the A. So we're going to start with the highest exponent here, which is the a to the third. What comes next? What's the next highest exponent? A squared. So 5a squared, b squared. We ignore that b temporarily. And then what would come next? 2ab. And then last would be negative 2b to the third. And so then on number 6, c comes first, so it would be c to the third, negative c to the third, and then what next? Negative 7c squared d squared. And then what's next? 5d squared, and then plus 13. So that would be the standard form there. Okay, so now we're going to talk about naming terms in terms of their degree and number of terms. Anybody still looking at this up here? So we need to talk about the word degree and what degree means. So degree, if only one variable the degree is the highest exponent. If there's more than one variable, we add the two exponents together. And whichever is the term with the highest sum. So we're going to classify according to degree. So if it's the degree of 0, it's called a constant. An example of that would be the number 5. 5 has a degree of 0, and that's called constant. So if we have a degree of 1, the examples that I gave you for the warm-up were all examples that had a degree of 1. What were those shapes?
Linear.
Lines. So we're going to use the word linear in terms of the name of the, according to the degrees, linear. So if it's a degree of 2, yes, and we use the letter Q, a word starting with the letter Q. What was that word?
Quadratic.
Quadratic. You're going to want to write these down because you won't necessarily remember them. So it's a degree of 3. Anybody have any idea what it would be if it's a degree of 3? So say we have this, x to the exponent 3. What's another way we can say that exponent? Cube. So it's a cubic. If it's a degree of 4, it is called a quartic. I know you don't have space there. If it's a 5, it's called a quintic.
How is that fun?
You can say 5th degree if you want.
How is that?
And anything higher than that, we just say what it is. So if it's a 7, it's a 7th degree. If it's an 8, it's 3. So now, if there's one term,
oh my God,
it's a something omial. 1. What's the word for 1? Monomial. Good.
Mono. Wait, mono is good.
So monomial. Yep. So if there's 2 terms, it's a binomial. Good. 3 terms. Trinomial.
No, it's not. Mix up.
So if it's 4 terms, we say polynomial, 4 plus. with blank terms. So if it's got 4 terms, it would be a polynomial with 4 terms. Okay, so now let's do some. I'm going to go on to the next degree.
Yeah, you can write the 5 by 3. No, I read it. I mean, wait, let's consider me like actually, I guess.
Thank you.
Let's see.
Okay, 6. You want to name that according to the degree and number of terms. So, degree would be, there's no variable, right? So that means it's a degree of 0. So what do we call that? The constant. And how many terms here? 1. So that would be called a monomial, according to the number of terms. Easy to get terms and degree mixed up. So number 8. It's got an x this time, so it's not a constant. X means it's called linear. Good. So it's a linear, only 1 term, so it's called what according to the number of terms? Monomial. Linear monomial. Okay, number 9, 7p plus 1. It's going to be binomial. So what's the degree on this one? The degree is going to be assumed to be this exponent, which is a 1, degree of 1. You don't have to write that, but I'm just writing that for clarification. So if it's a degree of 1, it is?
Binomial. No, it's not binomial.
It's a linear. And then 2 terms is binomial. So what about number 10? What's the degree on number 10?
Wait, it's binomial. No. Quadratic. No, I want to binomial. Like I said. No, yeah.
What's the degree on number 10?
Oh, it's 3. It's 3, so it's cubic.
Highest exponent?
3.
Highest exponent here?
2.
2. So the degree is 2. So what's that called according to its degree?
Quadratic.
Quadratic. Questions on that? Easy to get number of terms and degree mixed up. So it's a quadratic according to its degree. 3 terms, so it is a quadratic trinomial. Okay, what about 11?
Cubic.
Cubic, good. Exponent of 3, degree is 3. So we're looking at the degree. So the highest exponent is a 2. So yeah. I know. I've given you a ton of stuff today. So it's cubic, and then what? How many terms? 2. So it's called binomial. And what about number 12? So degree of 4. So that's quartic. And we don't have a specific name for 4 terms, so it's a polynomial with 4 terms. So quickly do the try. It's not on your paper, it's just up here. What would that be called according to the degree and number of
Huh? Oh, it was a long one.
So degree 5, right?
Quintic.
Quintic?
Yeah.
Quintic what?
Trinomial.
Trinomial.
No. Oh, yeah.
We don't use the words quartic and quintic a lot. I mean, yeah, quartic and quintic a lot. Starting and it's used a lot more. Questions on this before we move on to the last example, which is what most of the homework will be on, the last example. Okay, adding. We've done this before. So we just want to add some polynomials, and we want to combine like terms. So we're going to put our answer in standard form. So highest exponent first. So what's the highest exponent here? 2. So we're going to add those together, and it would be
2x. Wait, do you have to do that? Can you do like 2x?
so this is like a -1, right? -1 plus 2, which is
Oh. What?
what's -1 plus 2? 1.
Oh.
So that's just x squared. Does that make sense? And you can cross out the terms when you have added them. And then our x's, remember it's going in descending order, will come next. How many x's?
6x.
Plus 6x. We have 11 here, and we're adding a -5 or subtracting 5. 6x. And then we have 13 minus 23.
Minus 10.
Minus 10. Okay, when we're subtracting, we can't do just like we did on that first one. We have to do something first. What is it? What are we going to do with this? Because this minus applies to everything inside that parentheses, right?
Yeah.
So what do we want to do? Distribute. Good. So 4x squared plus 5x. This is like a -1, so we have to distribute the -1 to all of them. So -7x, -3x squared, and -1. So I like to write it out. There's a tendency, if you try to do that in your head, to make mistakes. And now we're going to add our like terms and go from highest to lowest, putting it in standard form. So how many x squareds do we have? 1x squared. Does that make sense? And then how many x's? -2x. We're adding the numbers in the front. And then -1. Okay, this one is the last one we're going to do right here. Okay, so we've got adding and then subtracting. So the subtracting we need to rewrite. We've got to distribute that negative. So it becomes -7, -8b, -5b to the 4th. I like to write them out. So again, we want to put it in standard form, so our highest exponent is, what's our highest exponent? 4. So we're going to look at those terms that have an exponent of 4. What do they add up to? -2. So these two add up to -9, and then +7 would be -2, b to the 4th. And then do we have any exponent of 3? Yeah, just 1, plus 2b to the 3rd. And then no squares, but we do have v's.
-5b.
We have,
-8.
yeah, just -5b, yep. And then we've got a -8, +8, those cancel, and then -7. That's your answer. Okay, can I get somebody to pass out the worksheet for me, please?
Okay. You gotta go. No, you gotta go. You gotta go. Nick, you got it. Bucket is bucket. Bro, what? No. No.